Let's talk about sampling. Our goal in statistics is always to obtain a random sample. That way we know we're not being biased or misrepresenting the population. Generally, we want what's called a simple random sample. In a simple random sample, any group of n individuals is equally likely to be chosen as any other group of n individuals. So if you envision a bag of M&Ms, let's let n here be the number 5. When I reach into that bag of M&Ms, does any group of 5 M&Ms have the same chance of being chosen as any other group of 5 M&Ms? If that is the case, then we have obtained a simple random sample. Some ways of obtaining this random sample are stratified sampling, cluster sampling, systematic sampling. Convenience sampling is probably not the greatest way of obtaining a random sample, but we're going to talk about it. And voluntary response sampling, which again, probably not the greatest way of obtaining a random sample, but it happens, so we're going to talk about it. And then multi-stage sampling is where we combine a couple different of those previous sampling methods together in steps or layers. So first, let's go ahead and define stratified sampling. In stratified sampling, the population is divided into groups where the members of each group are similar in some way. Then a sample is drawn from each of those groups. And a lot of times you'll see this definition written that the sample is drawn in a proportionate way to each of those groups. So if you have one small group and one large group, you're going to take a random sample from more random samples from that larger group than from that smaller group. Let's look at an example. So here we have a picture of our population on the left, and then we divide the population into strata. So the way it's physically shown to us in this picture is we have sort of the blue group and the teal group or the aqua group. So you could think of those two groups as men and women or adults and children or maybe different races. And so we've put this population into strata or layers or groups, okay? Now we select our random sample by randomly selecting members from each of the strata, from each of the groups. So you can see I've only selected 4 members of from the teal group, and I've selected 6 members from the blue group because the blue group was larger. So it's a proportionate random sample here. And then those several individuals, those 10 individuals that were circled, become my sample. So to relate this back to our Sierra College student examples, suppose we divide Sierra College students into groups using their current class enrollment. So, if you're sitting in a statistics class right now, you're in the statistics group or strata, whereas other students might be in a biology strata. This example actually makes more sense in the classroom than in an online setting, but go with me here. So then select a simple random sample from each class to obtain a sample that is representative of all Sierra College students. So from that statistics group, maybe I select 10 students. From the biology group, maybe I select 8 students. From the English group, maybe I select 12 students. So that's the idea behind stratified sampling. The next type of sampling method you'll come across is what's known as cluster sampling. In cluster sampling, items are arranged from the population into groups or clusters. So kind of similar to what we saw with stratified sampling, but now entire clusters are then randomly selected as our sample. So instead of randomly selecting members from each group, we're actually going to take the entire group to be part of our sample. A great example of this would be to look at the counties in a state. So here I have a picture of the state of New York broken up by a county. So we can see that our groups are the counties, or our strata are the counties, and then we go ahead and select an entire county as part of our sample. So these 5 red counties here become our sample. And we don't select any members from the other counties, so they don't become our sample. So does this obtain a random sample? It can, yeah. Are there flaws with it? Potentially. So here's kind of just an image of what this would look like if we were thinking about people here. We arranged these people into 5 groups, and we're going to go ahead and select the second and fourth group here. And we're not going to take anyone from this group, or this group. So back to our Sierra College example, consider all the classes taught at Sierra College to be the clusters. Now randomly select several of these classes and use all of the students in each of these classes as your sample. So now I'm going to take all of the statistics students. I'm not going to take any of the biology students or any of the English students, but I'll go ahead and take all of the art students. And I'm randomly choosing the statistics classes and the art classes. I don't have any bias necessarily over which of those clusters I'm selecting. In systematic sampling, the population items are ordered in some way, alphabetically, numerically, size, whatever it happens to be. And every kth individual is added to the sample. So if we line up all of the Sierra College students alphabetically, and then we select maybe every 5th student, we will create a systematic sample. Convenience sampling is not a random sample, but it is used often to obtain samples. Convenience sampling involves using results that are readily available. So in this image here, you can see that the person sampling is at the bottom here in blue, and they're just going to go ahead and take this person, this person, this person, this person, and this person as part of their sample because those people are closest to them. They can, she can reach out and shake their hands or, tell them, hey, come join my sample. Whereas the people out here in the extremities are not easy for her to get. So suppose you wish to find the average height of men in the United States by asking your male relatives what their height is. Is this a good idea? How is your sample flawed potentially here? If you want to know the average height of men in the US and you just go ask your dad, your uncle, your brother, your cousin, what could go wrong with that? Think about that. And then finally, let's talk about a voluntary response. These occur when the subjects themselves decide to be included into a collection of data. And honestly, this is probably the way that you have witnessed most data being displayed or collected around you. We are constantly asked to rate things on our phone, whether it's music or apps, your experience on a website, your experience with a product on Amazon. Those are all voluntary response samples.